In the second lesson of the section titled Extending the VLab Environment with VR Affordances of the Development of a Virtual Lab for Programmers course, you will go over Unity's VR project template, a complete, ready-made project based on the XR plugin framework and the XR Interaction Toolkit, pre-configured with default input system actions, and containing numerous interactive object samples and interaction mechanisms. The project can be used as a basis for further development as it can easily be tailored to the needs of individual application development efforts. The template project contains a complete scene consisting of a virtual room filled with interactive objects and UI elements. The purpose is to showcase a variety of techniques which you can later handpick and adjust to your own development needs without having to design and implement everything from scratch. The scene contains a lot of text components and other active elements, so it would be best to disable gizmos which will declutter your scene view significantly. The room contains UI panels, a teleportation anchor, a variety of interactable objects, and a video projection panel. When the template project opens, you will notice a tutorials panel on the right side of the editor. This contains links to essential documentation on VR development with Unity in general, the VR template project itself, online discussion forums, bug reporting pages, and a page for you to provide relevant feedback. You will notice that the scene contains a XR Origin game object. This is the complete representation of the user immersed into the virtual world, as well as all means of interaction available to them, including controllers and, if available, hands and gaze. The camera offset game object is a dynamically controller transform that ensures that the user views the virtual world from an appropriate height towards a better sense of presence. This is controlled by the XR Origin component, which acts as a bridge between the in-scene camera and the immersion device used. The XR Origin game object contains several additional components to enable control of the user's avatar in different ways. The Input Action Manager is an essential component that automatically enables and allows other components to consume input system actions. The XR Input Modality Manager enables handling of various input action types, such as gestures and body motion, by associating relevant events with appropriate hardware endpoints such as controllers and hand tracking. Similarly, the XR Gaze Assistance facilitates management and consumption of gaze tracking events. These components will operate only if relevant hardware is present and to the extent supported by such hardware. The actual camera contains a tracked pose driver component, among the usual camera-related components. Notice how the tracked pose driver is configured to receive input from ready-made input system actions which are available thanks to the XR Interaction Toolkit's sample assets having been imported into the project. The camera hierarchy also contains additional components for visual effects, etc. The XR Origin hierarchy also contains game objects and components responsible for interaction. For instance, the Gaze Interactor enables gaze-based user action, if supported. The controller game objects, identically configured for the left and right controllers, contain numerous components required to provide all the functionality required in a typical VR application. A key component is the Controller Input Action Manager, which maps controller-driven functionalities, such as teleportation, movement and interaction, with the input system via ready-made input actions as explained earlier. Additional components enable haptic input and gesture tracking, if supported. An additional components controls helper, tooltip-style callouts over the controller's controls, depending on whether the user is looking at the controller or not. The controller's hierarchy also contains components specific to the various types of interaction supported by the controller and controlled by the controller's input action manager. These include components to configure and control gestures, teleportation, and more. The XR-Ray Interactor allows configuration of numerous aspects of the user's abilities to interact with the scene with a ray. It links to the teleportation process and allows configuration of grabbing and manipulating objects. The line renderer controls how the ray is actually rendered in world. It is dynamically controlled by the XR Interactor line visual component, which allows for very sophisticated configuration of the interactor ray appearance according to the needs of your application. The controller animator component animates the controller's controls when the user handles them, towards intuitiveness and an increased sense of realism and presence. It provides for standard controls found in modern controllers, including the trigger, joystick, buttons and touchpad. The architecture can be easily modified and extended for different types of controllers. The affordance callout set of game objects control how the relevant informational callouts are rendered and shown or hidden as in world tooltips. The hand game objects are similarly configured in order to support hand tracking and hand-driven navigation and pose-based interaction, if available. The hand visualizer enables animated and realistic rendering of the hand while displaying tracked gestures and poses. The locomotion mechanism relies on a locomotion mediator components that acts as a gateway to various locomotion modalities and a XR body transformer which allows controlled and possible constrained application of locomotion inputs onto the user's avatar as actual movement. The mechanism provides for snap or continuous turning, all directed to the locomotion mediator and driven by ready-made input system actions. The template project's assets contain assets required for the proper operation of the XR plugin framework, configuration assets for the XR Interaction Toolkit, the XR Interaction Toolkit's hands sample and sample assets, and assets imported via the VR template project. All of the above are contained in packages which have been automatically imported as a result of loading the VR template project. You can inspect the packages used in the project via the Package Manager. You can also inspect relevant configuration of the OpenXR plugin used in the project settings. The XR Interaction Toolkit's starter assets contain numerous ready-made assets and resources that can significantly boost both your learning goals as well as actual VR application development. They contain numerous affordances, or effects triggered upon various types of interaction with objects, general-purpose animations, complete demo scenes, general-purpose materials, models and prefabs, various helper script components, controller textures, and visual effects. The most important asset provided is, however, a ready-made, complete input system action map covering almost everything that may be required in a typical VR application in terms of user input via a RABGAIF input modalities. These contain input action bindings for head and gaze tracking, interactions via controllers or hands, locomotion actions including moving, turning and teleportation, and interaction with in-world user interfaces. The hands interaction demo contains useful reusable assets for experimenting and developing with hand-based navigation and interaction. It includes all assets necessary to display realistic left and right hands and animate them as necessary. The two complete hands are available as prefabs for easy, one-step importing into your projects. The XR Hands sample is a great starting point for learning how to include animated hands and hand-based interaction into your applications. It is largely based on the XR Interaction Toolkit's sample assets and also contains scripts for configurable visualization of the user's hands in world. The VR Template Assets folder contains additional assets developed specifically for the VR Template project, which you can also reuse, or rely upon, for your own development and learning efforts. It also includes image and video resources for the tutorials displayed on the UI panels around the room. It is now time to run the project. Make sure that your VR Gear's runtime is loaded, your VR Gear is connected, and that you have prepared your VR Gear for tethered operation. When ready, run the project in the Unity editor. Experiment with interacting with the various UI elements in the scene. Notice how configured affordances highlight objects when necessary. You can interact with UI controls using the ray and trigger control or poke gesture. All UI panels are available for repositioning in the 3D world. Try grabbing an object and throwing it around. Watch how the controller's callouts appear when you look at it. Experiment with turning using the joystick. Teleport to a different location for a better view of the world and the room. Use the teleport anchor to return to the starting position. Keep experimenting. To practice, make sure you go over each and every component in the project and understand its purpose, function and place in the overall hierarchy. Also, try to adjust values in a targeted way and observe how various behaviors are affected.